Denmark 1912, a beautiful place to live and grow up, with its old monarch Frederick VIII recently replaced by Christian X, and their football team taking home silver during the Summer Olympics. It was a new and exciting era for the locals, especially for the newlyweds Margaret Norold and Niels Bohr, who was about to reach his next milestone in life. On October 7, 1885, Niels Bohr was born in Denmark, Copenhagen. Bohr was a physicist who had accomplished many things in his life, from getting married and having 6 kids to opening his own institution. Niels Bohr was an accomplished scientist. However, before any of that, he made one of the greatest contributions to the science community. In 1903, he attended his local university, Copenhagen University, where his father worked at, attempting to major in physics like his father, and with the help of Christian Christensen, he got ahead in his field by participating in the Royal Danish Academy of Science and Letters by writing his own paper on the surface tension of water, and won.
After he graduated in 1911, he moved to England where he hoped to work with J.J. Thomson, one of the greatest working minds in the industry, who after reviewing his work rejected him and did not want to work with him. However, in his time there, he was able to meet Ernest Rutherford, who did accept him for the way he was. But Rutherford was more experimental and loud. Bohr was more pen and paper and shy. Together they had a father-son-like relationship to the point where Rutherford invited Bohr for postdoctoral work at the University of Manchester. As they spent more time together, Bohr found out about Rutherford's model of an atom. He knew that there were 2 major problems with it, so he began figuring out a solution for it during his honeymoon.
In 1913, a professor asked him if he knew about Balmer's formula. At that time, Bohr didn't know what it was about, but once he did, everything clicked. Rutherford believes that the electrons surrounding the nucleus were scattered around randomly and moved in any direction they pleased. However, the 2 things that Bohr saw that were wrong in his model were that it would be impossible for an electron to spin around in any direction and not lose energy. If so, the atom would collapse in seconds. The next thing was that in the periodic table, elements were classified in such a way that it showed repetitions in the chemical properties of an atom. This meant that it would be necessary for each atom to follow a similar pattern to other atoms in order to explain their chemical reactions. Bohr had been trying to figure out a solution for a while now, but it wasn't until Balmer's formula showed that there were frequencies in every atom that were separated 10 to the -5th power in centimeters from the nucleus. With this, Bohr was able to come up with a formula that showed that there were quantized levels in atoms that electrons could travel through and preserve energy, and the electrons could move across these levels by absorbing energy and moving up a level, or by giving off energy and going down a level. With this, Bohr would write his paper on the constitution of atoms and molecules, which he had to write rather quickly because the year was about to end and others began to figure out the same thing he did.
In the end, Bohr came out on top with his model being the most accurate and won the Nobel Peace Prize in 1922. Despite this, some people opposed it, like Werner Heisenberg, but others, like Einstein, felt relief that the model was no more.
What I feel I have learned from Bohr is to not be discouraged by any obstacles, since there will always be other people to help you and get through them.
And what I've taken is to always be asking questions and looking for solutions, even if no one else is interested in the answer, because you never know what you might find.